Welcome to the launch of Nordic Clean Energy Scenarios. My name is Klaus Skytte. I'm the CEO of Nordic Energy Research. Nordic Energy Research is a Nordic institution under the auspices of the Nordic Council of Ministers. We finance research and facilitate the energy cooperation between the Nordic countries, Norway, Sweden, Finland, Denmark, Iceland, Greenland, the Faroe Islands, and Åland, as well as between the Nordic countries and the Arctic area and the Baltic countries. The Nordic countries have a unique and long-standing cooperation on energy. Now it's time to further the Nordic energy cooperation with the green transition as the new framework. The Nordic countries aim at being carbon neutral and at the same time being competitive and social sustainable. The Nordic region is well positioned for this. But we need to act fast in order to hit the unique window of opportunity to lead the green transition. With the Nordic Prime Minister's common joint declaration on carbon neutrality in 2019, and with the common vision of the Nordic region to become the most integrated and sustainable region in the world, it's obvious to look for Nordic solutions. Nordic Energy Research initiated the Nordic Clean Energy Scenarios due to the need for public available, research-based analysis that gather Nordic perspective on national and regional energy system, and then complement the ongoing work in each country. Through scenario modeling, Nordic Clean Energy Scenarios aim to identify and to help prioritize necessary actions and map the potential pathway to carbon neutrality. The work is both timely and important, considering that energy-related emissions make up almost 4/5 of the present Nordic emission. Energy is the backbone of the green transition. Today, we will guide you through the Nordic energy system and illustrate how the Nordic countries can achieve the Nordic vision to become the most sustainable and integrated region in the world, and to make the green transition towards carbon neutrality a reality. I hope that you, as well as I am, are excited to learn more about the Nordic Clean Energy Scenarios. Today's moderator of the launch is journalist and communication advisor. Please welcome Astrid Sæther.
Thank you very much, Klaus, for that nice welcome and also for setting the stage here today. Now, before we do the official launch, I would like to encourage you in the audience during the next 90 minutes to participate actively here. Not only by watching the broadcast and hopefully reading through the report itself, but also by asking questions during the event. We're going to have a Q&A session towards the end of the launch where all the experts will be present. Now, if you want to ask questions, you can do that and participate through Slido, an interactive tool which requires no kind of downloads. All you have to do is to open a browser and type slido.com, slido.com. You can see it on the screen now. And the code today is NCES 2021. It's rather logical. It's Nordic Clean Energy Scenarios 2021. Now, here you enter a forum where you can ask questions and comment. And the geniality of Slido is that you can influence what questions that should be asked simply by clicking like. The more likes a question gets, the higher the probability of me asking the question. Also, if you see a question that is similar to the one that you were planning on posting, please click like on the one that you saw instead, because that's going to help me out, not having to read through the same questions several times. You can ask questions anonymously or in full name. And regardless of that, I would like for all of you to specify who you are directing your questions to. That, of course, is going to help me out a bit as well. So thank you in advance. I'm going to monitor Slido as we go along through this, so don't hesitate to participate. Now, let's move on and into the program. Klaus Skytte just pointed and painted out the larger picture for us. keeping in mind the joint declaration from the Nordic Prime Ministers aiming at achieving Nordic carbon neutrality by 2030, there's no doubt, as he said, that time and action are of the essence. Something that has been strongly underlined by the recent IPCC's assessment report as well. So how do we get there? What needs to be done to reach the targets? What will the Nordic energy system look like in 2030? Let's start looking into those questions by lending ears to one of the coordinators of the Nordic Clean Energy Scenarios project, Senior Advisor Kevin Johnsen at Nordic Energy Research. Hi, Kevin.
Hi.
Good morning.
Good morning.
I'm eager to learn more about the background of the report. So tell me, how did you manage to work across the Nordic countries, knowing that we do emphasize different energy sources and use them differently throughout the Nordic region? How did you do it?
So thank you, Ruth. So first of all, what our director, Klaus Gide, just said, working across the Nordics is in Nordic Energy Research's DNA. So what we did for this project and this report was that we brought together a consortium of researchers and consultants from all the Nordic countries. And then we also put together a Nordic reference group and a Nordic expert team to kind of review and evaluate the result we found.
So it's quite elaborate. How much time did you spend on this particular report?
So we've been working from our side on this report for about 2 years, and the researchers and consultants have been working for maybe 18 months on the project.
Yeah. Now, you've done similar things to this before. What is new this time?
Yes, we have a long history in working with these kinds of projects. I think we did the first project already back in 2013, where we did a project called Nordic Energy Technology Perspectives. Like this time, we did it with a Nordic consortium, but also in cooperation with the IEA.
The International Energy Agency. Yeah.
Then we followed up on that project in 2016. And there's a lot of differences since those reports. So for all of you in the audience that kind of follows the end of this discussion, I think you all know that there has been a lot of changes especially since 2013, but also since 2016, when I entered the Nordic Energy Research. And for instance, the cost of solar power was a lot higher than it is today. We've also seen as you mentioned, the Paris Agreement and also the new assessment report from the IPCC that also highlights the necessity to kind of get the speed up and get these changes done.
We should have done it yesterday.
Yeah, of course. But looking into what we did differently in the analysis this time compared to the other projects, first of all, due to the need to reduce emissions faster, we have changed the target for the projects. In 2013 and 16, we also looked at the carbon neutral scenario, but back then we regarded that as a 85% reduction, and then the 15 remaining percent of emissions would be offsets. In this report, we look into a fully decarbonized energy system in 2050, while the greenhouse gas emissions actually are net zero in 2040.
So that's even more ambitious
Yeah.
in many ways. And at the same time, we see that we have the pathway to this end goal is even more bumpy than it was perceived to be earlier on. So how do you close this gap?
So what we also did this time compared to the earlier reports was that in the earlier reports, we had the targeted scenario where we wanted to be, and then we compared that to a business as usual, usually more or less 4-degree scenario, and with a slightly more ambitious, a 2-degree scenario. And we looked at what kind of extra ambition was needed to get to this carbon neutral scenario. In this project, we kind of took it for granted that we wanted to get there. But then we also recognize that there might be different ways of reaching that target. So we've developed 3 different scenarios that all, through different societal pathways, reach the targets that we would like to aim for.
So what are these 3 scenarios, Kevin?
So we have 3 different scenarios. We have the carbon neutral Nordics, where we focuses on the national targets of the Nordic countries and look into how, or investigate how to reach those in the most cost-efficient way. And then we have the Nordic powerhouse, where we dive deeper into how the Nordic countries also could reach the Nordic targets, but also help the remaining parts of Europe in their transition by providing carbon capture, electricity, and synthetic fuels through Power-to-X.
So that's a great business opportunity then for the Nordic.
Could be a great business opportunity for the Nordics.
Yeah, and the third?
And the third one is carbon neutral behavior, where we look into how changes in material efficiency and energy efficiency could help ease the transition. So what would be the effects on the energy system if we, for instance, if the passenger transport traffic for planes don't reach higher levels than we had in 2019, for instance.
You said carbon neutral twice, but it's climate neutral behavior, isn't it, for the third scenario?
Yeah.
Is there a difference between climate neutral and carbon neutral that you would like to elaborate on for us now, or is that too complex to do in 2 minutes?
So in our scenario, what we aim for in 2050 is a net zero emitting energy system. So the energy parts in 2050 is actually net zero. What we reach almost 10 years before that is a greenhouse neutral emission system, but that's also taking into account the uptake we have in the land use change and forestry sectors as well. So I would say that going carbon neutral might be even more ambitious.
Right. Well, I think we should say thank you to you, Kevin, so far, because we're going to meet you again later on. But it's time, don't you think, to dive into the details of the report and, of course, the scenarios, but most of all, maybe the 5 solution tracks that have been pointed out and defined through this report. So I understand this has been a huge effort to end up in this report, and you're going to tell us a little bit more about that later on. But so far, Kevin, thank you so much.
Thank you so much.
And to go into details, we have with us the project manager, CEO Marcus Wråke at Energiforsk in Sweden, and the project's scientific manager, Kenneth Carlson, who is co-founder and partner at Energy Modeling Lab in Denmark. So I think we're going to have them on the screen with us now. Good morning to both of you, and it's nice to have you with us. Hi. Now, we have a treat for you in the audience today. Not only will these two guys, Marcus and Kenneth, take us through the different solution tracks in the report, you will also get an additional insider's view. It's almost like an opponent, if you want, to the 3 technology tracks that we're going to hear about, i.e. Power-to-X, Bioenergy, and CCS. So now, dear audience, you can just lean back and get ready to be inspired and enlightened. And once again, please ask questions through our tool, slido.com, as we go along. NCES 2021 is still the code. Marcus, I know that you are eager to get started, and I'm going to leave the digital floor to you quite soon. So please tell us, what are the 5 solution tracks that you are suggesting, and why is direct electrification the most central one? Take it away, Marcus.
Thanks, Ruth Astrid, and good morning, everyone. Yeah, so let me just start then with introducing you to these 5 solution tracks that we've used to organize the research. We have this myriad of solutions that we can use to decarbonize our system. They all pretty much fall into these 5 tracks. And I'm just going to quickly take you through them. So the idea, of course, is to get rid of this big chunk of fossil fuels that we have in the system. And at the core of all our scenarios, we have direct electrification, where we replace fossil fuels directly with electricity, often combined with a battery. An electric vehicle is a good example. Then we have indirect electrification, or Power-to-X, where X is a fuel, where we use electricity to produce a fuel, often through hydrogen, which in turn then replaces the fossil fuel that we want to get rid of. The third chunk, or the third sort of solution track, is bioenergy. Of course, bioenergy already today is a keystone in the Nordic system, and we believe it's going to remain so for a long time. It's got many benefits, and we're going to hear more about how we can realize those in the scenarios later on from Kenneth Carlson. Finally, summing up this kind of technology aspects, we have carbon capture and storage. When combined with bioenergy, you have the BECCS solution, which basically means they can remove carbon dioxide from the atmosphere. That offers a possibility to ease the pressure on other sectors, buy us more time, and over the long term, most scenarios, when you look beyond 2050, we actually need to have those negative emissions in order to reach the long-term climate targets that we're set out to do. And then sort of on top of these 4 technology tracks, we have sort of a raster of lifestyle choices and behavioral changes that we may or may not do, that may create an easier pathway, or indeed make it more difficult to reach the targets that we've set out. And when you look at most scenarios and the pathways, basically the outcomes of those depends on what mix you have of these 5 solution tracks. And I think it's helpful to have kind of organize the analysis around tracks like this, because they often cut across value chains, which you don't see if you organize, for example, around sectors. So this is why we've sort of chosen these 5 tracks as our sort of main organizing principle for the analysis. So starting then with the first of these tracks, direct electrification, as Ruth Astrid said, it's really sort of at the forefront, and for good reason. I'd just start with not emission perspective, but rather the efficiency properties and the benefits of electrification, direct electrification, from an efficiency standpoint. Because looking at the example here with transport, what the graph shows here is how much energy you need to put in to transport one person 1 kilometer in the Nordic countries today. And when you look then what happens in our scenarios, you see a dramatic improvement in efficiency. And most of this actually is explained by direct electrification, just simply because an electric engine is much more efficient than an internal combustion engine when you use gasoline or diesel. And as a result of that, we see, especially in transport, direct electrification already accelerating, in particular in passenger. So what you see here is the stock of passenger vehicles in the Nordic system between now, 2020 at the top, where gray and black are the diesel and gasoline engines, moving very rapidly towards almost full electrification around 2045. And this is on the road. So what this means is that by 2030, we're probably seeing the last internal combustion engine sold in the Nordic region. And this is simply because it's cost effective. Most people today, it's cheaper over the lifetime of a vehicle to own an electric vehicle than a gasoline or diesel. This is not surprising. I don't think anybody's sort of, you've seen this before basically, but perhaps more controversial is that we basically see the same kind of development when you look at the trucking scene and goods freight. Just it's delayed by 5 or 10 years. And again, this is driven by the rapid decline in battery cost and the improved performance. They get more dense, they get smaller, lighter, and cheaper. And 5 years ago, we didn't see this at all. We saw a much greater reliance on biofuels and hydrogen as the sort of main routes here, simply because the batteries seem too heavy and too expensive to use as the main alternative for heavy freight. So this is maybe the prime example, but if we zoom out and look at across the economy, what we see in our least cost scenarios is a sort of an increase in the demand for electricity across all sectors, but perhaps not as dramatic as what you might get the impression from the public discourse. Now, Kevin alluded to one scenario when we look at more energy-intensive development in the Nordic region, which we call the Nordic powerhouse scenario, and what you see is a much greater increase in electricity demand, in particular driven by this pink area here, which is the production of electrofuels and hydrogen. So this is kind of reflects this great potential and the great benefits of electrifying processes and services directly that we see in our scenarios. So yeah, with that, I think I'll leave it back to you, Ruth Astrid.
Thank you so much, Marcus. That's very interesting. And I mean, obviously, the transport sector is prone to direct electrification, as you just showed us. But what about industry? What is the potential there for direct electrification?
Well, we do see a pretty significant direct electrification also in industry. We have loads of processes in industry where you need heat that could easily be electrified. Some of the challenges there are that when you need a lot of energy in a very short time, so high energy flow rates, or you need very high temperatures, it might be easier to go for either a fossil fuel like we do today, or another renewable fuel, perhaps produced through hydrogen, the hydrogen route. But we definitely see a significant potential to increase the electrification also in industry.
And you did underline the surprise when looking at the development of electric trucks or electrification of heavier transport. Could you elaborate a bit on that? Because I was a bit puzzled as well to see that. How is that going to be possible? Because we've been told that it's, you know, the batteries are too heavy, you won't get that far reach, etc., etc. So what's happening in that sector?
Well, there are two things going on here. The first one being, as I mentioned, the kind of revolution in battery technologies that we've seen playing out over the last 10 years. Most people didn't expect the rapid cost declines that we've seen. And also the energy density of the batteries is getting higher, so they get smaller and lighter. But it's true that also in these scenarios, we rely on assumptions that this development will continue. And it's far from certain, actually, and you need both the technology improvements, of course, but also you need the charging infrastructure and the strengthening of the grid that go along with that in order to realize these scenarios. So I would say it's kind of less certain than on the passenger side, but it certainly looks the most competitive at this point.
Now, the Nordic region, I do believe it's well situated for direct electrification. But what about other regions in the world, if you want to sort of make an example? I mean, we have an abundance of renewable energy sources, but that's not the case everywhere else in the world. Have you made any reflections on that?
Well, it's a good question. You know, I think that electricity, of course, it's a great resource that we have from the hydro and the wind that we have in the Nordic region. But even going beyond and outside of that situation that we have, you know, just the efficiency improvement that I mentioned before for direct electrification makes it really attractive. In particular, if the resource, in this case, electricity, is scarce, then you need to be very careful how you use that energy resource. So I think the ways that you're going to produce and distribute the energy and the electricity will be very different if you go to a sort of emerging economy or an economy where you don't have access to the abundant resource that we have. But certainly the main track and the kind of rule of thumb that if you can electrify a process directly, you should do it because it's cost effective and it's energy efficient.
Marcus, I would like to ask you a question from the audience that just popped up in Slido here. So there are actually several questions, but I'm going to save them for later. But there's one. Which life cycle perspective is applied to efficiency improvements of transport, from oil well to kilometer of transport, or from produced electricity to kilometers?
Well, we've sort of used a well to wheel perspective in this. So we try to capture the whole life cycle of each fuel that we have. But having said that, it's really difficult to do that, you know, in the granularity that you ideally have to do if you want to look closer at, for example, how you produce, you know, the metals that go into batteries and how you transport the fuels. We haven't done that. That hasn't been the focus of the study, but we've used to the best of our ability, we've used assumption and kind of results from the literature to reflect those perspectives in these numbers.
Marcus, I think we're going to stop our Q&A on the direct electrification for now. There are still questions that could be asked. I'm going to get back to them later. Now, direct electrification will only get us this far. What about the hard-to-abate emissions? Marcus, it is time for you to take us to the next solution track that we just saw and that you've briefly mentioned, the Power-to-X. And an important buzzword here, of course, is hydrogen. And I wonder, will hydrogen make it this time? Marcus, the word is yours once again.
Yeah, thanks, Ruth Astrid. Yeah, you're right that there's a lot of sort of discussion and, if you wish, hype around hydrogen. I would argue that it's not just hype. And if, to answer your question, yes, I think hydrogen will make it this time. I think the situation is different, and certainly when you look at the possibilities to use hydrogen, they're much greater now because the costs are lower. The way that we produce and distribute hydrogen is more efficient than we expected. So the situation is different. But nevertheless, when we kind of model this, it's not so obvious that hydrogen is the cheapest option. So looking at those scenarios, and the first one where we've kind of minimized the cost of reaching these climate targets, we don't actually see that much hydrogen coming into the Nordic system. When we push it a little bit further and we kind of make more optimistic assumptions around the cost for hydrogen production and force a bit more hydrogen use into some sectors, we quickly get a lot more, as reflected here, where we have a scenario with much more Power-to-X and particularly hydrogen. What's interesting here is just both the magnitudes and the kind of span, the differences between those targets or those scenarios that both meet the climate targets. And of course, the electricity required to produce this hydrogen is really high. So then you're going to kind of go leverage. So this is what sort of drives a lot of the big span that you can see in the assessment of how much electricity do we need in the Nordic system and in the individual countries between now and 2050. It's kind of explained by this graph where we see, depending on how quickly and to what extent we rely on hydrogen and other electrofuels, you'll see a dramatic difference in how much electricity we'll need. So this is just looking at the water system. If you then add the kind of the European perspective to this, of course, you get even greater leverage. So again, looking at the situation now, this graph shows electricity production in the Nordic region. You see in 2020, we had about 400 terawatt hours. In a least cost scenario, we get a significant increase, reflecting the graph that I showed before. But not, you could argue this is not so dramatic. It's high, but it's still manageable. But if you then look at a scenario where the Nordic region and the European Union, which has a really ambitious hydrogen strategy, where you kind of envision that hydrogen will be a centerpiece of the decarbonization of the entire European economy, then it opens up a great potential to export either electricity, clean electricity from the Nordic region to produce hydrogen on continental Europe, or indeed to refine the product and produce the hydrogen and other fuels here in the Nordic region. That's a great opportunity, but could also have a tremendous impact, of course, on our system, as reflected on this graph, where you see how much power we would need in a scenario with very, very high sort of penetration of hydrogen technologies and related Power-to-X fuels. So again, there are two sort of key points here. First is the big span, and the numbers start getting pretty daunting, going from 400 to close to 1,400 terawatt hours per year. That requires a tremendous build out of infrastructure. And secondly, you can see those dark and lighter blue bars at the bottom there to the right, which is wind power. So most of this additional electricity production we will see coming from wind power. Of course, that has a pretty big impact on the landscape. Right now, offshore wind looks more expensive than onshore wind, but perhaps it's worth paying a premium to get some of those turbines out of sight, so to speak. Some of the fuels that we need can also be produced on offshore situations and exported directly without even reaching the shores of the Nordic countries. So, but this kind of raises loads of questions around social acceptance and feasibility of these scenarios that I think is kind of not recognized when you talk about this hydrogen and Power-to-X track, which again has a lot of attractiveness in it because they can produce high temperatures, high flow rates, long ranges of vehicles and so forth. So when you look at particularly wind, I think it's not going to be limited by cost competitiveness or lack of demand for clean electricity, but rather how many turbines, to put it bluntly, are we willing to accept in our landscapes in the Nordic countries? So it kind of raises a lot of questions around this track that has not so much to do with the technology properties, but also other sort of political and social aspects.
Thank you, Marcus. And as you said, you're raising a lot of questions, and we're going to add some questions here now, because it's time to invite today's first opponent to the digital scene. Dr. Birte Holst Jørgensen is senior researcher at DTU Wind Energy in Denmark, and she's an internationally renowned expert in energy science, technology, and innovation policy. Her CV is quite substantial, and we can't go through it all, but I would like to point out that she was director of Nordic Energy Research between 2005 and 2009, according to her, some of the greatest years in her career. Now, she is ready to challenge the report's conclusions on hydrogen and Power-to-X. So, Birte, what are your initial thoughts on this particular solution track?
Thank you very much for inviting me to give some tough questions to the authors. But before that, I would like to congratulate you with this comprehensive and well-written report. I enjoyed exploring the pathways and the solutions tracks. And I noticed two things. One, that decarbonization is unlikely to push the wholesale electricity prices up. And two, coming from DTU wind in all scenarios will have a prominent role. But to my first question, when looking towards 2030 and 2050, it's also good to look back on previous expectations and scenarios. And just 15, 20 years ago, hydrogen was also very high on the energy policy agenda, with enormous expectations to the development of the hydrogen economy. And just let me remind you that we had the first public refueling green hydrogen station in Reykjavik in 2003. We also had the Clean Urban Transport for Europe and test of 27 hydrogen fuel cell buses in 9 cities, including Stockholm. We had the Scandinavian Hydrogen Highway Partnership with extension from Gothenburg to the Norwegian Hynor, and also to the Danish hydrogen fuel buses in Copenhagen. And just to mention the EU attempt at that time, the president announced 2.5 billion euro for two large initiatives, the hydrogen with large-scale production of hydrogen and hydrogen about hydrogen communities back in 2003. Neither of these two initiatives were realized except for two small feasibility studies. So, Marcus, what is the main difference, except from the cost reduction, or what, from today's expectation to Power-to-X and then the hydrogen hype 15, 20 years ago?
Well, I think the main explanation really is about cost. You have, first of all, the cost of producing clean electricity has come down more rapidly than most people thought back then. And secondly, also the production equipment to produce hydrogen, so the electrolyzers basically, have declined more rapidly than most people expected. And also, notably, we expect that rapid decline in cost to continue. So that's kind of one, and I would say the most important reason why the outlook is more positive now. But then you also have, a great push from the EU, as many countries in the EU have sort of preclude the use of other energy carriers like bioenergy for other reasons, and they strike other options off the list. You kind of end up with hydrogen as being one of the only alternatives. And as we are connected to the European Union system, if there's a great push to innovate and roll out hydrogen there, we're going to see benefits also in that realm in the Nordic region. And finally, I think a third aspect is that the pace of change that we see is necessary now, and the targets that are being put in place are so stringent that you need solutions like hydrogen that you perhaps didn't envision 15 years ago, when you had more time basically to do this.
Okay, my second question is that different ways of producing hydrogen, they have different colors, the green, the blue, the pink, and also the gray. The traditional way of producing hydrogen today is by reforming natural gas. but that's very difficult to compete with this traditional way of producing hydrogen. My question to you is where to expect the breakthrough, the market breakthrough, where to expect early adopters of green or blue hydrogen?
Well, I think in the Nordic region, it's definitely in long distance transport. So shipping would probably be the first option we see, where you see it coming into the model through ammonia. Aviation is probably the second. So those are the kind of no-brainers because it's hard to find other solutions. Then you have a lot of chemical industries in the Nordic region that use hydrogen as a feedstock, where they would probably be quite early adopters as well. Then, of course, we have, especially in Sweden, we have a few steel companies that are pushing to use hydrogen to revolutionize the steel production. So that looks pretty likely. So in the Nordic region, those are kind of the four areas where we see it coming in soonest. If you look globally, the really big one that we don't talk much about is fertilizer production, where you use tremendous amounts of hydrogen that currently are produced, like you say, through natural gas reforming mainly.
But then you have mentioned all of them. So which one will be the first? Actually, I just referred
shipping. I think if I had to choose one, it's shipping.
Shipping. Okay, that also corresponds with the recent DNV report, where they expect 42%.
Oh, they're good people at DNV, so yeah, hopefully we're right. Okay,
my last question is that when we invest so much political capital in indirect electrification in Power-to-X, I worry that the continuous incremental R&D related to renewables and, of course, also wind energy and the transformation of the power system is forgotten. So my last question to you is how to balance the expectations, avoid hype, and assure a continuous focus on technology R&D, irrespective of contributing to direct electrification.
Yeah, well, that's a hard question to ask a researcher, right? We want to have more resource to everything. But if I had to choose one, you're right. I think that direct electrification, as reflected in our scenario, is kind of a clean electricity, and direct use of that is at the core of everything. So I have to choose one. That's where you should put the emphasis. But since we don't know, it's true. We don't know what's going to happen. We don't know if these assumptions and expectations are being realized. I think it's wise also to kind of not put all eggs in one basket, and also spend research on other sort of potential pathways. And you could mention, high efficiency, large scale heat pumps, not talked about a lot, but has got tremendous potential in some areas of industry. You have, the whole flexibility issue. How can we increase the flexibility of the existing system using existing infrastructure? What policy instruments are necessary to create the incentives to roll out the charging infrastructure? So there are loads of areas, like you say, that kind of lie beneath the hype and are necessary to get going to realize these scenarios. They are pretty ambitious.
You guys, the image of me on the screen is a sign that we have to move on, but I could have listened to you for hours. It was very interesting and inspiring. So thank you so much, and so far to Marcus and to Birte, because we're going to meet you again later on. And I can assure you there are lots of questions coming in and continuing to challenge you. So we're going to get back to that later on, because now it is time to move on into the journey of the different solution tracks and look at how the role of bioenergy in the Nordic energy system will be played out. How substantial will it be in 2030 or even in 2050? Kenneth Karlsson is now ready to give us some answers, and he is also ready to be challenged by our second opponent in a while. But first, let's get an overview of the potential of bioenergy in our Nordic region. Kenneth, the digital floor is now yours. Take it away.
Thank you, Ruth. As Margaret mentioned, we don't see bioenergy go away. And we are saying here in our report that the role is changing, but it's still important. And what we saw years back in the old studies was that bioenergy would be used a lot for heavy transport, shipping and aviation and so on. But as the electrification kicks in, as Marcus just mentioned, then we actually see another role for bioenergy, and it actually releases some bioenergy for purposes. So I'll just start with the 3 takeaways from our analysis on bioenergy, and then I will go a bit deeper into some of the results. So this development we see in transport electrification will lower the pressure on bioenergy, and and that will give us opportunities to still have bioenergy play an important role in the system. So we see in our analysis that it stays in many sectors, most sectors, and play, and especially in interim time, play a role in most sectors. But also it takes up. You can see that the biomass and biofuels are filling up the gaps where we are missing some solutions. We have an easy to handle fuel here that can be stored, and it can also take the place until we have newer fuels and electrification in place. But of course, we always have the discussion when you're talking biomass about the sustainability, and that is something that will continue to be an important topic and something that we should look a lot more into in the future. But if we look at the bioenergy use in our scenarios, then we actually see a slight increase in bioenergy. So here, if we take the carbon neutral scenario, we can see that in 2020 we were using around 350 terawatt hours of biomass and imported biofuels. The light purple is imported biofuels, and then we can see a slight increase to a little above 400 terawatt hours. And the changes we see in this period is that we see industry and commercial and agriculture is using slightly more biomass, while in power and heat sector we see a decline, maybe not as strong decline as was expected before. Then on the top we see that more and more of the biomass goes into producing of fuels, biofuels and so on. So we're not only seeing that the power to X fuel comes in and to fuel the shipping and aviation, but also biofuels to a large extent. But how is this different from what we've seen before? So I just put the old study here from the Nordic Energy Technology Perspective from 2016 to see what demand we were envisioning in that study. And you can see that here, especially biomass to produce biofuels was a huge demand. And that was actually the big challenge we addressed in that study, that the Nordic actually had to import biomass to make the transition, which was critical. So what we see today, mainly because of electrification of the transport sector, we see that actually we have a much lower demand for biomass, bioenergy in 2050. And more important is actually that we stay within the potential we have in the Nordics. This potential is from a recent study by Poiro, looking at the Nordic countries' potential for bioenergy in 2030 and 50. So we can see, so even though we increase the demand, we still are able to keep us within the potential we can see. But of course, that is not now we say this what will be also discussed a lot in the future is but how much can we then use to energy, because there will be other demands for biomass, and we haven't been looking a lot much into that in this study, but just pointing out that this will be the discussion to come, how to ensure that we only use sustainable biomass and how much can we actually use for energy when we need the biomass for chemical industry and materials as well.
Thank you so far, Kenneth. And I guess part of that discussion might be arriving here today already, because as I said earlier, we have another expert ready to challenge the findings and the conclusions in the report. And specifically on bioenergy. And I'm soon going to invite Oras Tinkinen to the digital floor. He is a senior advisor at Sitra, the Finnish Innovation Fund, where his main focus is carbon neutral circular economy. He is also, amongst others, partner at Tyrski Consulting, providing expert services in the fields of climate, energy, and sustainability. Today, he joins us to discuss bioenergy, the vast field of bioenergy. And I know that he has several questions for you, Kenneth. So, Oras, without further ado, what are your comments and questions regarding the report?
Well, let me also start by congratulating on the analysis. I've read the report and I find the analysis solid and robust. But I do have some critical points to make about the role of bioenergy indeed. One thing that struck me in the report was that you stated that in the Nordic context, biomass is not a scarce resource. And here I have to disagree. I do think that sustainable biomass in particular is a scarce resource already today and already in the Nordic countries. And I find there are several reasons to that. One is something you already alluded to, which is that we are already today importing biomass. And when we import biomass, we export the environmental impacts of producing that biomass. Secondly, there is always an opportunity cost related to using biomass. If we use less biomass, we would have more space for using forest as carbon sinks and storages. And then finally, already today, our biomass use is having a quite sizable impact on nature. For instance, here in Finland, it is actually the way we use our forests that is the biggest primary driver of biodiversity loss. And that, of course, cannot continue as it is today. So this all leads me to ask the question if we are indeed relying a bit too much on biomass and if we should explore more the sustainability constraints on the amount of biomass we can actually use in the future.
Yeah, thanks a lot, Oras, for these very good questions. And of course, they are not easy to answer. But so just let me make it clear that like when we have done these scenarios, we are trying looking at different options, reaching carbon neutrality. We're not saying this is how to do it. And we have some limits that we work within, and one of the limits was the available biomass. But this is very much up for discussion. And as you said, we're already importing a lot of biomass to the Nordics, and that is why we have made a sensitivity study where we block the import of biomass to the Nordics. So can we actually manage without importing? And we can, as we can see, these are what the resources I show here is Nordic resources. But if we don't block imports, we will import because it's cheaper. Some fuels and some biomass residuals are cheaper from abroad. So, and we see that a lot today. Denmark is importing a lot of biomass, for instance. But these sustainability issues and biodiversity issues are very important to take into account. And when we are getting this amount of biomass in the solution, it's not saying that this is the level that we need. We could actually go much further with electrification that we have done. But when we ask to get the cheapest solution, as we have done here in our modeling system, then we still, because a lot of biomass biomass is really cheap to use, and it's easy technology to use in the boilers and so on. So, but we could, if we get some constraints on biodiversity or something, or we want to use it for other things, we could put more pressure on that resource in this and see, okay, what would be the next, and then industry would have to electrify more than we see in our results here.
Indeed, and let me also use the opportunity to really congratulate you on the sensitivity studies or the variants, as you call them in the report, because they really touch upon the key issues, I find. My second point would be related to the future prospects of biomass use, because my understanding is that there will be a growing competition of the scarce sustainable biomass resources, especially when it comes to circular economy, where we want to replace our fossil and other non-renewable resources with renewable ones, most notably biomass. And actually, Sitra commissioned a study recently from Material Economics looking at the supply and demand of sustainable biomass in Europe. And one of the conclusions there was that the expected demand for biomass would probably be 40 to 100% larger than the expected supply of sustainable biomass. So there seems to be an increasing competition of this very limited scarce resource. And I understand that your study looked at energy specifically, and you did a really good job at that. But as this is an integrated system and there will be other users for that very same pot of biomass, I wonder if you can discuss that a bit.
Yeah, but I fully share your concern here, and I could just say that when we are doing studies like this, then you find you bump into some challenges. Last time that when we did the Nordic ETP from 2016, we pointed out that this amount of biofuels needed for the transport sector was a big problem, because can we import biofuels to the Nordics when we have so much biomass here? Probably not in the future. So that was like we put up like this is a big challenge. And from this, one of the takeaways here from this study is also that we still have a challenge on biomass, because we have now we see even an increased competition about the resources, and that is something that should be looked more into. We haven't done it here, but that's especially, if I should point out something that you should continue working on from here, is this competition on biomass and the sustainability of biomass, to make sure we don't invest in something that it turns out that it will be not feasible in the future.
Indeed. My last point would be related to the transition from the current use of biomass to these more valuable uses in aviation, maritime sector, some industrial uses, and others. I do see that recognized really well in the report. I just wonder, to me, the speed and scale of this transition from current use of biomass, mostly in power and heat, and transport, to these more valuable uses in the future. To me, that transition seems to be relatively slow in your scenarios. I wonder if you can discuss that as well.
Yeah, and that is actually also a bit of surprise, and I'll come back to that when we discuss carbon capture and storage, because the reason for why we see biomass staying in the power and heat sector is because of the need for negative emissions, actually. So that is, when you look at all challenges at once, you have to solve the problem somehow, and we are trying to solve the cheapest way. But this is also to put up the discussion: is this what we want? Is this how we want to solve it?
And that gave me a great transition to the next track. So thank you so much, Orans, for challenging Kenneth and the report. And you're both going to be back later on. We're going to keep you, Kenneth, for some longer now, because we are, as you said, going to look into carbon capture and storage, or CCS as we call it. According to the report, CCS is essential for reaching the carbon neutral objectives of the Nordic region. So I'm curious to find out what the cost will be. And I wonder, are we technologically ready to deploy CCS at the necessary speed and scale? So I'm going to give the word right back to you, Kenneth. Take it away.
Thank you, Ruth. And when we are saying or concluding that we need carbon capture and storage, actually we need negative emissions in the Nordic countries. And that is because in some of the countries we have industries which are hard to abate. And in some countries we actually have large emissions from land use, which can only be compensated by negative emissions. So that is there are several reasons for why we need the CCS in the Nordic countries. So if we jump into that, how is the Nordic actually in place to do this? As you asked also, are the technologies there, are the facilities there, and so on? But actually, when we look at the Nordic countries, we have a huge potential for storing CO2 on the ground. We have old oil and gas fields, we have Sjælland aquifers in Denmark, we have basalt rock in Iceland, which actually can store a lot more CO2 than we can ever emit from the Nordic countries. So there could even be a business case for the Nordic countries to take CO2 from other countries or international companies. But that's another story, and that's something where we have to fix the market for that to work. But so if we look at the Nordic country, what we see in our scenarios is, of course, the amount of CCS that we need will depend both on the cost of CCS, but also of what the countries, you can say, need for negative emissions. And we just take a look at the map here, then we can see that Iceland actually need a lot of negative emissions because of their land use emissions mainly, and also because they have ambitious climate targets. Denmark also needs quite some negative emission because of the land use. Then in Sweden, Norway, and Finland, they are a bit more flexible, because here you see the two bars. The lower bar is where we are using high prices for CO2 storage, and the high bar is where we're using like the area, the projected prices for CO2 capture and storage. So you can see in Denmark and Iceland, we don't have much choice than to go for negative emissions, while in Sweden and Finland and Norway, they have industries that can do more, electrify more, instead of still continue with some fossil fuels and then using CCS. So the solutions, the reason for CCS in countries are different, but what we see is that we have a need for negative emissions, and at the same time, we can see that the Nordic countries are well suited for carbon capture and storage. And we already have projects running both in Norway and Iceland, but also new projects is on the way in Denmark and Sweden on this. So when we're saying, yeah, the negative emissions are important, are necessary, then okay, how much do we need and how fast? So you can see. So actually, we need the rollout to start pretty soon, because we need to scale up until 2035 as we see it. And that is also because many of the countries have targets in 2030 where we need some negative emissions to actually reach those targets. So we need a rapid ramp up and then continuous increase and more stable level from 35 ahead. We also see that 90% of the CO2 that we are capturing in our scenarios are from biogenic sources. So that is to be able to get negative emissions. We still have some 10% from fossil energy, mainly in some heavy industries. And then also, you also need some CO2 to produce fuels from power to X fuels. So when we produce hydrogen in electrolyzers, we need to add some carbon to produce different types of fuels. So what we see here is that 20 to 30% of the captured CO2 are actually reused in fuels. So, and then if we look at the graph here, we can see the blue area is the bioenergy carbon capture and storage, so-called BECCS, which is a huge chunk. And this is combined heat and power plants with added CCS. So here we use biomass for producing heat and power, and then to capture the CO2. And actually, this is mainly one of the main surprises in this study, is that we keep so much CHP with bioenergy, which is like in Denmark, it was envisioned that this should be phased out because we shouldn't use the biomass on heat production, heat and power production. But actually, we see as still it looks like the cheapest solution. So that is where our models suggest we go if we are looking for the cheap solution. Other solutions are, of course, waste incineration plants. We also see some hydropyrolyzers, and we see some carbon capture in the oil and gas sector at refineries. But the cost of these different solutions are not far from each other. So it could switch between the different types of CCS technologies. And especially direct air capture is something that might come in at some point. It's very expensive right now, but projections says that the price will be much lower in the future. And if this speeds up, then direct air capture could be a solution to bring in earlier in this. So as we mentioned, there might be some, we see there are some hard to abate emissions, and we end up still having around 30 million tons of CO2 emitted to the atmosphere from the Nordic system in 2050. And if we just look at where we came from, so today the Nordics are emitting around 170 million tons, and the main part from transport. But as Marcus was telling you, transport, we are on a very fast track in reducing that emission from transport. Then there's 3 equal-sized emissions here from the upstream sector, that is the oil and gas and refineries, and power and heat sector, and industry. And if we then move to 2030, you can see a tremendous cut in these emissions. And these cuts are outbalanced, and this level that we end up here is counterbalanced by the captured CO2 I showed you just before. So we see the main part here being left is from industry, but industry, as we also said, have more options to decarbonize that is not utilized in these scenarios. So it's not like we could even do more than what we show here.
Great, Kenneth. Thank you so much so far. And of course, we have another expert ready to ask questions and comment on the CCS section of the report as well. It is time to welcome Mona Mølnvik, one of Norway's leading experts on carbon capture and storage. Now, she's both research director for gas technology at SINTEF Energy Research and director of the Norwegian CCS Research Centre. So, Mona, what are your initial comments on the CCS content of this report?
Thank you for having this opportunity to both read this report and to follow this launch. It's really impressive. And it's a pleasure being here representing the CCS area, since this is one of the cornerstones which we will have to develop to meet climate targets. And I've been working with CCS for many years, so having another report is it's a pleasure, and it's really good to see that the Nordic countries goes together to evaluate the possibilities to meet the climate targets. In 2015, there was a scenario, a vision for carbon capture and storage towards 2050, launched in the Nordics Center of Excellence, funded by the top level research initiative, the Nordic top level initiative. And the ambition then was surprisingly almost the same amount of CO2 captured as you have in your report, a little bit less than 20 million tons of CO2 per year. But it had a wider span of sources for the CO2. So we have had some years now developing the CCS area further. In between, we have had the European taxonomy coming, and just since the January 2021, the price of emitting CO2 in the ETS scheme is has increased from a little bit above 30 euro per ton to over 60 today. So my first question is, are you ambitious enough in this report when challenging the CCS for the Nordic countries? Shouldn't the Nordic countries capture and store more CO2 than you suggest?
Thanks, Mona, for the question. And yeah, so it's all the matter of your boundary conditions and what you include in your analysis. And here we have included the Nordic countries, and actually we linked the energy system model that represents all sectors in the Nordic countries with a power system model for all of Europe, especially to track where to produce hydrogen, where we also had the electrolyzers. But what you're asking here is also, we should also track where to actually capture the CO2. So we haven't done that on a European scale, and that could be very interesting because, as I said, the Nordic countries have huge potential for storing CO2, and we have the facilities, we have the knowledge and know-how, and so on. So when this international market comes, and it will, then the Nordic players are in a good position to do that. So we haven't looked into that potential, but obviously there is a huge potential for the Nordic countries storing CO2 for others.
Thank you very much. And then my follow-up reflection is related to hydrogen production. Since I understand you have used the green route from renewable energy via electrolyzers to hydrogen. called green, and we know we also have the possibility from producing hydrogen from natural gas with CO2 capture, then called blue. And we heard earlier today we have many colors of this hydrogen. And in a recent report called Hydrogen for Europe, it was estimated that Europe would need maybe 100 million tons of hydrogen by 2050, and there will be a mix of blue and green. So can you make some comments to this, not including blue in this study?
Yeah, so you can see for the cost minimization scenarios, we don't see so much hydrogen coming in because other solutions turns out cheaper. But because we expect a future demand for hydrogen on a global market, it will be interesting for the Nordic countries to look in that direction, especially as you see the big European market here. So, and I must admit, we haven't looked into this competition between blue and green hydrogen. And as I said, it is a green hydrogen we choose to export from the Nordics in the high power to X study scenario. But this is, like I said, on the biomass, it needs further work on where is the resource plenty and who should use the resource in the future. And we still also on hydrogen, this needs more studies on exactly the competition between blue and green hydrogen. And so this will very much depend on the demand. Will the demand be for green or blue, or is blue also acceptable, and so on. But definitely it's an option for, especially in Norway, to produce blue hydrogen.
Thank you.
Mona, as you can see, I'm on the screen again. If you have a very quick and short question, I'll allow you to ask it. Otherwise, we have to move on. But do you have a quick question at the end?
Yes, I have. You say competition. I would like to say we need all. So in my opinion, it's not a competition between the solutions. It's about how can we bring enough clean energy, clean industry forward, and then we need to cooperate between blue and green and between CCS and CO2 capture as a solution for many emitters. And we have the Longship project evolving in Norway now, and we really work hard to bring in the Nordic countries also in this CCS chain. So good luck with the work to come.
I can see Kenneth is nodding there. So thank you very much, Mona, and also to you, Kenneth, for this particular track, because now we're about to enter the fifth and the final solution track, where our role as consumers and citizens is under scrutiny. Are we, you and me, ready to change our behavior in order to reach carbon neutrality? What political instruments and measures are needed to make that change happen? It all sounds like a huge challenge to me, but I'm eager to hear from you, Kenneth. How do you suggest that we go about this?
Yeah, again, when you do studies like this, there's a lot of things you want to do a lot more and look much more into, and this behavioral change is definitely one of them. But we decided to include it because it's so important. What we do, how our demands develop in the future influence our energy system directly. So instead of like making a very detailed sociological study of what we can do, we have tested different options. So what if we did this? What if we did that? How big impact would that have on the energy system? And as you notice here on the figure here is that the idea with behavioral change is that it can squeeze the amount of needed energy. So and of course, when you reduce the size, the amount you need, then also you make it easier to actually reach your target because you don't need to install so much hardware to actually supply it. So if we dig a bit deeper into what we actually have done in the carbon neutral behavior scenario, that we want to just look at some parts of what behavior influence could have on the results. So passenger transport is a big thing, of course, in this. It's huge energy consumption, and today also a biggest part of the emissions. So what if the passenger transport stabilizes on 2019 level instead of increasing as always assumed in these scenario analysis? How would that affect the results? And also we look at what if consumption is reduced. So we have a reduction in output from industry at 10% in 2050, which should reflect that demand is changing by the population, that people tend to maybe spend their money more on going to the theater and other things instead of buying durable goods. And then another point that we have found interesting here to include is what if we increase car sharing? Well, how could that impact, especially the cost of this? So these are the things we have included. And if you look at the bars to the right here, you can see our final energy demand divided on fuels in 2020, and then in the carbon neutral scenario and the carbon neutral behavior scenario. But maybe the change is not so big. What we see is a reduction in demand by 7% in 2050, which doesn't seem a lot, but actually there are some changes that is worthwhile looking at. But also you should remember that we have, like, for all the scenarios, we have the same target, same emission reduction target. So that means if you lower your demand, then actually you give room for the model to spend more energy on, like, industry, like being less efficient some places. So it also depends on how you're doing such analysis. So we could really go much further with these reductions if we were focusing on how far can we go with this. So just bear that in mind during the presentation here. So, but if you look at one of the things where we can see where the changes in behavior would have huge influence on the result is transport. So if you look at the demand for transport we have had until now, it has been like slowly increasing. There's a dip in based on Corona. You can see it aviation. The dip is a bit larger. So we have on the left we have the transport per capita, the passenger kilometers per year, and to the right we have the used fuel for aviation. So in the carbon neutral scenario, our central scenario here, we see a continued increase of the transport demand as, like, continuing historical trends, and that causes we assume that the aviation goes back to normal, and then the drop in the fuel is not because we not keep increasing demand for aviation, but because the airplanes becomes much more efficient in the future. When we then look at the carbon neutral behavior, then we assume a drop in demand, and of course that drop that goes both for cars, but also like it's all passenger transport, so also aviation. And you can see this gives a huge decline in fuel needed for aviation, of course, and that is money saved. But of course, you can say the price you pay is you don't go abroad as much as you would like to do, maybe. So there's and that is the case with the behavioral change, that there's a price to pay, but maybe the price is okay if you exchange it with something else that give you meaning in life. So, and just to mention this drop, both the drop in fuel of cars, but also the car sharing part. If you one car shared in a car sharing pool or something can actually replace 5 to 6 privately owned cars. So you can see if everybody, we are not assuming everybody, we are assuming like 20-30% population switch to car sharing, then you can actually reduce the amount of cost tremendously. And this means, together with the fuel saving, that this scenario is 10 billion euros cheaper a year in 2050 than the carbon neutral scenario. So it really it have a huge influence on the cost, and of course it have influence on our daily life because we are changing how we are living. So there is the behavioral part that where we can influence our demand by changing our behavior and demanding things that are not so energy consuming. And then there's the whole part about public acceptance I just want to illustrate also, which is very important. And Marcus mentioned it in the beginning, because when we are building out, when we are going to produce more and more electricity to supply to cover all the sectors who are going more and more electric, we need wind power and solar power. So if we look at the amount of wind and solar power we have onshore today, it looks like this. But in the future scenarios, we need a lot more to cover that demand. And if I showed you what was offshore, this is extremely much more than this. But just just to say, so just in our carbon neutral scenario, we more than double the amount of capacity for wind and solar, especially solar onshore. And going to the Nordic powerhouse, it's increased a bit more. But if we also look at the high power to X scenario, it's a lot more. So you can see, so we have relaxed so we have assumed in these scenarios that the public acceptance would be like this, so we can accept more and more wind and solar power. But it's also telling you that if we can't accept that, then we will increase cost of this transition, because then we have to move offshore with all the solution, and that is more costly. So you can see behavior and public acceptance have a lot to do with the price of the transition of our system.
Great, thank you, Kenneth. The price is one thing, but of course, what prices are we talking about? Because now we see, when it comes to public acceptance, that people are reluctant in many different areas geographically, but also politically, to sacrifice nature on behalf of, for instance, this grid that you were talking about. So how do we solve that? Because, I mean, one thing is what we accept, another thing is how we do behave. And we have to do this very short, because time is running out for us now. So have you looked into this in the report at all, how to get that public acceptance, which is so important?
No, we haven't been studying what is needed. I know good colleagues at Beatrice's colleagues at TTU Wind have just released a study on that, on how acceptance of wind power can develop. And studies like that are very important to see if we because one thing is that we are showing here that technology-wise and time-wise, we can decarbonize the Nordic energy system. So, and it's not costly. We can see we can stay within the same power prices as we have today. And because the development in all these technologies, the prices are going down, we actually, even the most costly part is CCS and the power to X. So that is like what is topping up the cost of this. So actually, we should actually, can't point out enough the importance of this acceptance, because if we don't get the public acceptance of this transition, then it can simply block everything. So also what we didn't show here was transmission lines, the need for transmission lines. So along internally in the Nordics, to balance the system, we need a lot more transmission lines, but also to harvest this potential export of electricity to the surrounding world would also, we also need to increase high voltage transmission lines. And that is something that is highly debated in all the countries. So this is, we haven't a solution, but we definitely want to point out that this is something we should discuss, and we should discuss it now, because we are in a hurry to solve this.
Definitely. And we're also in a hurry to engage in that discussion. And I would like to invite all the experts and there we are. Yeah, I think we're going to have all of you here. So both Markus Wråke and Kenneth Carlsen, who have presented the key messages from the report, together with Mona Mölvik, and Birte Holst, because it's time to answer some questions from the audience. And I have to say, it's been boiling out there on Slido. So what we've done, realizing that we won't have time to go all through the questions, some of the questions have been answered directly in Slido, as you can see. And by the end of a week or so, all questions will be answered nevertheless. But I would like to have some perspective from the panel on one of the trending questions, which is, what do you think? And this is to all of you, so I just will ask you to raise a finger to show me whether you want to reply to it. What do you think are the main barriers to reach carbon neutrality in the Nordic region in each of the 3 scenarios. And Marcus, he's already replied shortly to that, and he says that it's a big question. But to the rest of the panel, what do you think? Is it the cost? Is it policy? What is it? Or is it technology? Oras first, and then Birte. Go ahead, Oras.
Well, incidentally, actually, just a couple of weeks ago, Sitra released a study looking at specifically that question, but in the Finnish context. And I recognize that there are differences, important differences between the 5 Nordic countries, but I think many of the main conclusions will still apply to the whole Nordic region. And we would start with the lack of clarity and vision about where we need to go. We have the carbon neutrality targets, but we don't necessarily have separate targets for sinks or negative emissions. We don't necessarily have sectoral targets, and we don't necessarily have the pathway to those very long-term targets. We very often lack incentives for some very key solutions. We talked about negative emissions and CCS. We don't have the incentives in place for those solutions to be attractive from a purely commercial perspective. So we need to introduce the incentives. And then finally, I would just add the different kind of bureaucratic permitting legal obstacles to making the necessary investments. Those are still quite significant in some regards.
Thank you, Oras. Birte, you were fast in raising your hand, so go ahead.
Yes, I think it's important to emphasize that there's path dependency associated with energy infrastructure. It takes time to change the course of this very, very heavy container ship. So what matters is political commitment and courage. But in order to do that, I think it's important to have Nordic lighthouse projects. And just to mention a few, it matters that Norway, long time ago, has invested in the Sleipner storage of CO2. It matters when Denmark, for example, invests now heavily into energy islands. I'm a little bit more undecided what I think about the investment of 11 floating wind turbines, the high wind Tampen, to deliver clean electricity so that they can take out more oil and gas in from the North Sea. But I think these lighthouse projects actually matters very much.
Thank you, Birte. And that's the latter point you made is, of course, a part of a huge discussion. And I've seen questions raised about that as well here. So we'll just have to, I think we have to move on a little bit now. And I saw that Mona as well, you raised your hand, didn't you? Yes.
Yes, I support what has been mentioned and about having a direction, not just setting emission targets in 2050. And I think we will see it's not about carbon neutrality, but net zero CO2 emissions. I think we will meet that requirement before we reach 2050. And actually to plan and which investments and which development do we need to do now to reach the emission targets in 2050. We can't just continue to shuffle those ambitions ahead of us.
A question regarding the Nordic perspective as well. To what extent is it feasible that we can agree on tracks together, Nordic tracks, for instance, for CCS pathways or hydrogen production, for instance? Do you have any comments on that? And I'm looking at the screen to see if there are. Yep, Mona.
Yes. We are now in Norway. We have Sleipner, we have Snøhvit, where almost 1 million tons of CO2 has been captured and stored in Sleipner for 24 years or 25. And now the project Longship is under development, and there will be captured CO2 from the cement plant at Brevik in this project, and hopefully from the waste incineration at Klemetsrud into and captured, transported by ship along the coast and stored under the sea bed in the North Sea. So this project is developed in a way that it has a transport and storage facility which is open for other sources, and of course also open for the other Nordic countries. So going more into developing scenarios and ambitions for this Longship project and how to connect to this project from the other Nordic countries, I think that would be very interesting.
Great, thank you very much. So I'm looking at the panel now and also looking at the time, and we are running out of time more or less because we have another section that we would like to present to you as well. So I think for now, we're going to say thank you so much to Markus Wråke and Kenneth Carlson for presenting the messages, and also to the rest of the panel, Mona Mølnik, Oras Tynkkynen, and Birte Holst Jørgensen, for participating and sharing your views and perspectives. It has been greatly interesting to listen to, and I know that the audience have enjoyed it as well, as there are many, many questions being asked, and they will be replied to in a few days. But now, sorry. We have been talking a little bit about Nordic collaboration, and that is also an important keyword for our next and final presentation, because collaboration is necessary if the overgoal is to be reached for the Nordics to be carbon neutral in the near future. But what should the main areas of collaboration be? Now, that is something that Kevin Johnsen, he's more than happy to share that with us now. So take it away, Kevin.
So thank you, Ruth. So first of all, I hope that you've all enjoyed the presentations we had and also the short Q&A session. I hope that we have managed to get the message across that the results that we have found in this project shows that this transition is possible, but that we also need to prioritize. And what I would like to show you here are, let's see if this works, is that some of these there are some goals that we might want to achieve, but they might not be. We might not be able to kind of go through all of them at the same time, to achieve all of them at the same time. So what you see here are 5 different goals that we could try to follow, and one of them that I think are really important and that we all agree on is that we need the pace of the transformation to increase. And that might be in conflict with a transition that is low in cost, and I think that most of the Nordic countries would agree that that could be a trade-off that we would accept. Another goal that I think we have to achieve as well is that we need to have a transition that is socially acceptable. What that might mean is that it could be that the Nordic countries will do less to support the European transition than what we technically have the potential to do. Or we need to have a discussion with the Nordic public that this is something that we would like to achieve together, and then get the acceptance for that kind of support to the rest of the European society. And then lastly, what we also see in some of the developments we see in the Nordic communities is that some of the businesses are actually going for the long-term business strategies that not necessarily follows the results that we find, particularly regarding to what's the lowest costs, because some of the businesses has an idea of where they want to be in 2050. So Marcus briefly mentioned the Swedish project called Hybrid, where they produce hydrogen to produce emission-free steel. I think in the scenarios we find that it's slightly cheaper to go for carbon capture and storage, but then the businesses would like to do this in a way without emissions and without relying to carbon capture and storage. So they already invest into a solution that they believe in the future. So these are some of the conflicting goals that we might see in this transition. Then we've also highlighted 4 target areas for Nordic collaboration that we find when we try to conclude on the results, and that we would like to suggest to the Nordic governments. So first of all, we would like to recommend that there should be a stronger coordination of and commitments to the Nordic power infrastructure and planning of that. Secondly, as you've seen in the presentations, there is a need for a Nordic cooperation on an integrated offshore wind and grid development. I think we also need to have a common vision and discussion on the role for Power-to-X production in the Nordics. What role should that take? And then lastly, we also need to have a common Nordic carbon capture and storage strategy. So I'll go a little bit further into each of these. So what you see here is, as mentioned in the presentations, that there is a significant increase, and this is from the Nordic Powerhouse scenario, in the production of wind power in the Nordic system. And you can see the terawatt hours to the left, and then you can see the total share of the power market on the left. So what we see here in the Nordic Powerhouse scenario, where we see quite a high level of production, also to produce some of the Power-to-X that we talked about, is that the offshore wind production will go further than 100 terawatt hours, meaning that it will be several times larger than the total Danish power production today. And this, of course, will impact the national grids that we have. So we would recommend that there should be a Nordic cooperation on developing these grid plants, being in this integrated system that we have, and also the impact that this will have on those grids. As you also see here, looking at the wind share, it's increasing quite significantly. And what you don't see here is also solar power PV that will also increase. And that also has some effects on the power infrastructure. So what you see here is that the exchange between the trade flows between the Nordic countries are likely to increase. And what we find in one of the scenarios is that there's likely to be what we find is a 63% increase in the exchange capacity between the bidding zones towards 2050, and that's quite a significant increase. And let's take an example of today, where the power prices in Norway are quite high, especially here in Oslo in the south. It could be a benefit if we could have some of the cheaper electricity from the northern parts of Norway and the northern parts of Sweden transported to where we are. But we also know that these transmission systems are complex, and that building out this infrastructure also takes a long time. So what we recommend to do is that we should find the no-regret investment options, and also strengthen the Nordic grid expansion plan and give a strong political and financial backing for this build-out of this build-out of the power infrastructure in the Nordic countries. We also talked about, and we have talked quite a lot about, is the Power-to-X production in the Nordics. And Marcus also talked about the differences between the cost-efficient scenarios, where we look for what role would the Power-to-X play in the Nordics, rather compared to a scenario where we aim for providing a significant part of the European demand for Power-to-X, as you can see here. And while he talked about the effects of that, what I would like to highlight is that being in this interconnected system, and especially in the power sector between Norway, Sweden, Denmark, and Finland, if the national strategies diverges, they still influence the other countries. So if, for instance, Finland and Denmark aim for being large Power-to-X producers for the European market, that would also heavily influence the Norwegian and Swedish energy system. So I think it would be a good thing to do to talk about this at the Nordic level, and kind of try to find a common vision for what role we should have for this. And then lastly, as we also talked about, Kenneth talked about, there is a need for a cooperation on carbon capture and storage as well. What you see here is the million tons stored in each country in 2050, but also the possible storage plans. And as well, we also know that the infrastructure for this is quite expensive. We find in the scenarios that there's a good potential for bioenergy capture and storage using the Finnish and the Swedish district heating systems. But then we also find that the Icelandic and Norwegian storage places are quite suited for storing this. So there should also be a common Nordic CCS strategy where we can kind of build on those advantages each country has. So to conclude on this, we believe that a successful coordination in these areas will lead to a more efficient solution at a lower cost for the Nordic countries. And moving towards the end here, I would like to thank all the project partners for participating in this project. I would especially like to thank Energiforsk and the Energy Modeling Lab, but also IVL, NMBU, EA Energy Analysis, Thema Consulting Group, Tekni, Profu, and VTT for their efforts in this project. It has been a real pleasure to be working with you. And concluding, I also hope that all of the audiences would like to go to our website and download the report. You've only seen the tip of the iceberg. There's a lot of information in the scenarios that we would like you to look at. And for those of you who are extra interested in these sort of things, we also have other supplementary material available. So we have an open access model, we have a database with Nordic energy statistics, we have a technology catalog where you can look into all the cost estimates we have for the different technologies, and we also have a web tool where you can dive into the different scenarios, test out the carbon capture and bioenergy sensitivity analysis, and compare the results for different countries. So thank you.
Well, thank you, Kevin, for this very clear, very efficient roundup of why the Nordic perspective is so important. So I understand this has been elaborate work and you're inviting the audience to use it, and I hope that they do. So thank you so much, Kevin Jonsson, so far. And it is time. I know that 90 minutes is not a lot when we're going into such elaborate reports as this 174 pages long report is, and I hope it's been interesting and inspiring to all of you. And now we have Klaus Gudde, the CEO at Nordic Energy Research, back with us here. And 90 minutes, they just flew by, actually 96 minutes to be precise. I'm sorry that we've been, going past our time frame, but time is of the essence. And that's also one of the important conclusions that you made here today, that we need to act fast. So what happens next, Klaus?
So first of all, I would say, as you, this is really, for me, it's been an eye-opener, this scenario project, that it actually has shown that energy cooperation and the Nordic energy cooperation will be the backbone of the green transition. And also, it's always been an eye-opener that the Nordic position is well positioned for this. I mean, but as you just mentioned, time, we need to act fast in order to reach our climate goal and to establish this common Nordic carbon neutral region. So what happens next is, just as Kevin just said, I hope that the data, the scenario, the report that have been launched today will be used as a common knowledge for further discussions of the different actions that we can take in order to create a common Nordic region that is the most sustainable and most integrated in the world. That's what I hope we'll do.
And the Prime Ministers, they signed the joint declaration in 2019. So I guess this report is already on the table at different ministries around the Nordic region now, isn't it? Or at least it should be.
Yeah, it should be. I sincerely hope that. But of course, it's a political decision which action to take.
Yeah.
We just make the common knowledge basis that actually make sure that we all have the same foundation to make the right decision. And that is research-based and it's open access, as Kevin just said. So I think there's a political action that needs to be done, but there's also this, as Kenneth just said, that everybody can go in, play with the resource. So I encourage everybody to log into the homepage of Nordic Energy Research. It's www.nordicenergy.org. Download the report, read it, use it. That's the most important thing from now, I think.
And with that, 8 minutes past our deadline, I think we should say thank you for today. to everyone who has participated here today. And thank you to all the experts and everyone joining in. So good luck with the rest of the work.
Thank you very much. And thank you for excellent moderation. And thank you all out there. More than 500 have signed off this event. It really warms my heart to see so many joining in and actually following up on us. It means that our work is worth something, and then you rely on it. So thank you.
Thank you and goodbye.